now we will discuss a very important topic, that is the biasing of combination of similar MOSFETs, or we can say biasing of combination of similar MOSFETs. So, rather than going for theoretical analysis, I will be taking the numericals directly and the approach which is to be adopted for solving such type of numericals. So, let us take very first example, and most of these questions are from a gate. We are given two transistors here, that is we are given two MOSFETs rather. This is one MOSFET having feedback from the drain side. Then we have another MOSFET again having feedback from the drain side. This terminal is shorted. This is plus 5 volt. This is T1. This is T2. And you have to find this MOSFET is T2. This is V dot. Right? So, question here is, remember one thing, whenever drain is shorted with the gate terminal, that MOSFET always operates in saturation region, that is fixed, right? Now, we are given the transconductance parameter of T1, that is K1 is equal to 36 microamperes per volt square, and K2 equal to, that is transconductance parameter of the T2, that is 9 microamperes per volt square, that is given. Threshold voltage of both transistors is 1 volt. Question here is find V naught, that is this voltage. So, it is very interesting. What is voltage VGS1 and what is voltage VGS2? Please see carefully. Voltage VGS2 here is output voltage. This voltage is same as this, so this is V naught. What is voltage VGS1? Please see it carefully. This voltage is 5 volt minus V naught. So, VGS1 is 5 minus V naught. Drain current here, this is ID1, this is ID2, and remember the gate current is always 0 here, IG1 is 0 and IG2 is 0. So, whatever is current here, same will be here. So, ID2 will be equal to ID1. So, ID1 is what? ID1 is transconductance parameter K1 into VGS1 minus VT whole square. So, K1 is given to you, that is 36. VGS1 is what? That is 5 minus V naught. VT is what? 1. So, minus 1 whole square. So, that is 36. 5 minus, not 5, I will take it 4 now, 4 minus V naught whole square, that is ID1. This is equation 1. Now, what is ID2? ID2 is K2 VGS2 minus VT whole square. So, this K2 is how much? That is 9 microampere per volt square. VGS2 is V naught. VT is what? 1 whole square. So, that is ID2. But you can see, since both are connected in this combination, so ID1 must be equal to ID2. So, this implies ID1 is equal to ID2. Why? Because both are having in series, both drain and sources are in series. So, that gives 46 into V4 minus V naught whole square is equal to 9 V naught minus 1 whole square. So, you can simplify this equation, and after simplifying the equation here, that is by simplifying this combination, that equation we get the voltage V naught equal to, that is 3 volt. You can simplify, but I am writing the result directly. This was a simple question. Fine. Now, let us take another example. based on the combination of MOSFETs just like this. So again there are two MOSFETs given in the circuit, and that was also again this was the question in gate whatever we discussed now. Now let us see the next question, that is again based on the biasing of combination of MOSFETs. The circuit is from gate 2011. You are given a MOSFET. This biasing voltage is 6 volt. Again a MOSFET like this. This is grounded. This is connected to the point here. This is voltage Vx. This is voltage 5 volt. Fine. For this W by L is 4. For this W by L is 1. That's given to you, right? And mu and C naught X for both transistors is 100 microampere per volt square, right? The threshold voltage is again same for both the transistors, that is 1 volt. Find Vx. You have to find Vx, but be careful here, drain current must be same. Why? Because this is isolated, so remember gate current is 0, here as well gate current is 0. So whatever is drain current here, that same current will be flowing here. Say this is ID1, this is ID2, say this is T1, this is T2, right? So first of all let us see what is the voltage VGS. This is VGS2, this is VGS1. So what is VGS1? VGS1 is equal to 5 minus Vx. 5 minus Vx. What is VGS2? That is simply Vx. See it carefully again. What is VGS1 minus Vt? That is 5 minus Vx minus 1. That is 4 minus Vx. And what is VDS1? That is 6 minus Vx. But you can see here VDS1 is greater than VGS1 minus Vt, and that indicates therefore T1 operates in saturation region. Why? Because expression of drain current is different for maybe different for this and this. Whenever the drain terminal is shorted with the gate terminal, MOSFET always operates in saturation region. So this is operating in saturation region. Both are connected like this, so drain current, this drain current must be equal to this drain current. That's for sure. This is in saturation region, but I don't know the region of operation of this MOSFET. So how to find? Find the voltage VGS, then from there find voltage VGS minus threshold voltage, find voltage VDS. If voltage VDS is more than VGS minus VT, BJT operates in saturation, and if voltage VDS is less than VGS minus VT, it operates in ohmic region. So here VGS1 minus VT is 4 minus Vx, VDS1 is 6 minus Vx. So this is the condition, and therefore T1 operates in ohmic saturation region. So drain current for saturation region is what? ID1 is equal to what? Mu n C naught X by 2 W by L into VGS1 minus VT whole square. So ID1 must be equal to what? That's 100 by 2 into W by L is 4 here for this. So 4 multiplied by VGS1, you can please see that VGS1 is how much? 5 minus Vx. So 5 minus Vx. What is threshold voltage? 1. So minus 1 whole square. So this gives 50, 200, 5, instead of 5 minus 1 is 4, so 4 minus Vx whole square. So that is ID1. That is ID1. Then what is ID2? Expression of ID2, again this is operating in saturation region, and for saturation region this is the expression of current. So mu n C naught X by 2 into W by L, but please see carefully, it is 1. So W by L into VGS2 minus VT whole square, and this is 100 given to you by 2 W by L is given to you, that is 1 here into VGS2. VGS2 for this, and VGS2 is Vx. So minus Vx minus 1 whole square. Say this is equation number 1 and this is equation number 2. But from the circuit you can see this is 0, this is 0. So whatever drain current is here, so that must be same as this current ID2. So ID1 is equal to ID2. So when you put here, ID1 is what? 100 by 2 into 4 minus Vx whole square. Or I'll, rather than writing this, I'll write 200 here. 200. That is equal to 50 into Vx minus 1 whole square. So you can simplify this equation. You can solve this equation for Vx, and that Vx comes out to be the value of Vx from this result. This expression comes out to be, that is Vx is equal to 3 volt. You can solve it yourself. Fine. So this was the question again in gate. Let us take another example, similar example. Here again we have the combination of MOSFETs, and that combination is applied or given biasing voltages. So I'll be again taking question from gate, because there are a lot of questions from MOSFET biasing in gate exam, and especially from combination of MOSFETs. From the combination of MOSFETs, many questions have appeared in gate exam. So let us take the circuit. You are given this circuit. We have two MOSFETs. This is basically combination of PNP and NPN. So I'll be taking this question separately. Again, combination. So I have, instead of resistance, we have the simple MOSFET like this, that is shorted. We have the drain voltage VDD. Again we have another MOSFET like this. This is given 2 volt. This is grounded. Fine. So you have to find, this is M2, this is M1, right? Given, you are given mu n C naught x W by L, that is given to be 1 milliampere per volt square. That's given to you. Threshold voltage is given to you, that is 1 volt. Fine. So you have to find VDD, for which your M1 operates in saturation region. You have to find the voltage VDD. This is given to you. Fine. Whenever drain is shorted with the gate terminal, remember the MOSFET operates in saturation region. So this is for sure, M2 is operating in saturation region. The drain current is ID. Remember, in case of MOSFET, gate current is always 0. Fine. So now what is voltage? Say this is voltage VGS1, this is voltage VGS2, right? So what is VGS1? Voltage VGS1 is definitely equal to 2 volt. Fine. What is, say this is terminal S. What is the drain current for this? Say ID2, this is ID1. Fine. So to find the minimum voltage here, I have to assume the same current ID1 and ID2. So what is ID1? ID1 means for this, that is equal to mu n C naught x by 2 into W by L VGS1 minus VT whole square. This is given to you. 1 milliampere per volt square. So I will be taking drain current in milliamperes. So into VGS is 2 minus 1 whole square. So that is 1 milliamperes. So ID comes out to be 1 milliamperes in this case. Fine. So let us proceed further. VGS1 is 2 volt. ID1 is given to you. Now what is ID2? ID2 here is mu n C naught x by 2 into W by L VGS2 minus VT whole square, right? So now VGS2 in this case is nothing but VDS2 . So what is VGS2? VGS2, please see it carefully, that is what? VDD. This voltage is same as this voltage. So this is VDS2, this is VDS1. Fine. So VGS2 is nothing but VDD minus VDS1. This voltage is nothing but this voltage is same as this voltage. So this voltage will be VDD here. So the VDD minus VDS1 will be VGS2. And VDS1 is, remember, there is a condition here. See it carefully. This MOSFET should operate in saturation region. Find VDD for which M1 operates in saturation region. So VGS1 is how much? See it carefully. This is equal to VGS1 is 2 volt. For at boundary, we can say at boundary between saturation and ohmic region. What is VDS1? That is VGS1 minus VT. VGS1 is 2, this is 1, so that is 1 volt. That means for boundary between threshold, between saturation and ohmic region, VDS1 is not given to you. But for saturation region, at the boundary, I can find VDS at the boundary between saturation and ohmic. So it was not given to me, but I know if it is operating in saturation region at the boundary, I can take VDS1 equal to VGS minus VT, because that is the boundary between saturation and ohmic, and that will be the minimum voltage required for saturation region. So VDS will be VGS1 minus VT, that is 1 volt. So I can write this equal to VDD minus 1 volt. Therefore drain current ID2 will be equal to what? That is this is in milliampere, remember this. So this is 1 milliampere into VGS2 is what? VDD minus 1, threshold is 1 whole square. And since both are connected in such a way, from circuit, what do we get from the circuit? You can see from the circuit, I get from the given circuit, ID1 is equal to ID2. So this gives VDD minus 2 whole square is equal to 1, and that gives the value of VDD, and you can please see this comes out to be VDD equal to 3 volt. So this is the question which appeared in GATE, and year was GATE 2015, 2 marks question. So that is, these are the questions which have appeared in GATE a number of times, questions based on 2 MOSFETs. So see these questions a little bit seriously, because there is always possibility of such type of questions in GATE. So just wait for my next video where I will be talking about the another biasing circuit of MOSFET. Thank you very much for watching the video.